So now we're going to look at compound angles. Compound means lots of things together, compounded, added together. But if you think about angles, if you have cos of 50 degrees and cos of 30 degrees, you can't just add those two together and make the cos of 80 degrees. Try it. You'll see that cos of 80 degrees is totally different to what you did when you work out cos of 30 and cos of 50 and add them together. It doesn't work like that. So we need some new rules. So these are the compound angle rules. And we get a whole load of formula from your formula sheet that looks like this. So you'll see there's actually 6 rules. 2 for sine, 2 for cos, and 2 for tan. You'll notice on this formula sheet you've got sine of A plus B along the top equals sine A cos B plus cos A sine B. Or you can have sine of A minus B, which is equal to sine A cos B minus cos A sine B. They're just grouped together on one line there with the plus or minus symbol. Notice for the cos on the next line, cos of A plus or minus B. On the second part, on the expanded part of the formula, the sign's the other way up. So that tells you that cos of A plus B is cos A cos B minus sine A sine B, and cos of A minus B is cos A cos B minus sine A sine B. Then the tan formula, because tan has to be a little bit different, tan A plus B is tan A plus tan B, all divided by 1 minus tan A tan B, and tan A minus B is tan A minus tan B, all divided by 1 plus tan A tan B. So as I said, there's not a lot to do with these, it's just another load of identities that you may need to use to help prove some other things. Or indeed, you may use to help simplify some things. For example, a question might be to expand the following. Sine of pi over 2 plus a. As soon as I see two things within a bracket like this, I know I can go to my compound angle formula. So using the compound angle formula at the top, sine a plus b, I can rewrite, using the right hand side of the equation, this into sine of pi over 2 cos a plus, because the plus at the top, cos of pi over 2 sine a. Okay, where do I go from here? Well, pi over 2. Pi over 2, 180 divided by 2, that's the same as 90 degrees. And we know from our sine and our cosine rule, angles and graphs, that sine of 90 degrees is the same as 1. And cos of 90 degrees is equal to 0. So that makes my equation a bit easier. Because sine of 90 degrees is 1, I can now write sine pi over 2 cos a as simply 1 cos a. Cos of pi over 2 sine a is going to be 0 sine a. Obviously we don't write 1 cos a, and 0 times anything is going to be 0, so simplifying that, I get simply cos a. Nice and tidy. Obviously not every problem is going to come out as nice and simple as that and end up with something easy, but you may find you need to use your exact values to help get some exact answers for some of these.